Hello. So this is my first time doing this. This is a practice run, basically. Share my screen. Oh, I must. Hey, sorry about that. Okay. Let's share my screen. Okay, so what I'm going to do today is not solve an exercise, but actually add a new exercise to the Gleam track. So each track has this nice tool that's called configlet. And if you do configlet info, it tells you which exercises have been solved and which have not been solved yet. Have been added to the track. So today I've decided as a test run to pick list ops. And so we can take a look at the problem specifications for list ops. And you can see that there is a bunch of different tests and different cases represented in this JSON file. So all tracks on exercism share, all tracks on exercism implement exercises that are specified in this repository. So if you look at the exercises, there's a whole bunch of them. Maybe some of them you've solved. But so all of these you will find in different tracks. Let me check something. Okay. So let's go for it. So the Gleam track actually has a generator, and there's a script called generate practice exercises. And this is really convenient. All you need to do is to write the name of the exercises, and then it will update configlet, download this file that I just showed you, and parse the file, the JSON file, and generate all of the files that are needed for the exercise, including, most importantly, the tests. So the generator ran, seems to have worked, and here is, so if I do git status, you can see that two things have been modified: the config.json, which is the configuration for the whole track, and a folder listops has been added into the practice exercises. So I'm opening it over here. So let's take a quick look at the instructions. Basically, listops is, it's a nice exercise that implements basic list operations. It's really nice for functional programming, because one of the first things that people get used to are these operations, something like map or reduce. Some languages call them fold. Actually, Gleam calls them both fold and reduce, depending on which side it does the association. And a whole bunch of other ones, filter, length, and all that stuff. So let's take a look at the tests that the generator generated. So yeah, so this is the generated folder. It's not too bad. There's going to be some cleanup to do. Right. And we can take a look as well at the source file that was generated. And the source file generated has all of the functions that we need to implement. So append, concat, filter, length, map, fold L, fold R, and reverse. So the first thing we're going to do is maybe clean up these. You will see that this is list one, list one. Those are basically labels. So each list is labeled in these functions, but maybe in this case it's not really needed. For example, here we have when we only have a single argument, we don't need to label it because there is no ambiguity at all. And for append, I would say that maybe there isn't a need either, because it's pretty, well, maybe it's not so clear which is which actually, so let's leave it for now. But let's not call it list one and list two. Yeah, actually let's call it that. It's not too bad for now. So for filter, the function will not be a string, but because the types here are very different, it's not necessary to label them. So another thing is in Gleam we'll be piping functions into each other a lot, and so the piping operator sends the top of the pipe into the first argument of functions. So in Gleam, it's better to use the main data structure that we're going to be focusing on as the first argument, and then the function maybe is the second argument. So by the way, the function will be a function of, let's say, a to bool. And all of these unknowns should probably be a, or yes. It's unknown because the generator doesn't always know. What the types are, which is fair enough. I'm also going to change all of the ints into a. I think we can keep oops. I think we can keep all of the functions generic. Good. So concat will take some lists and no, that's not right. It should take a list of lists and return a list. How did that happen? Filter should take a list, a function from A to bool, and return a list. Length should take a list of A and return an int. This was correct. The map should take the list first. And then a function. Let's say from A to B, and the result will be a list of B's. This was okay. Fold L. For fold, having the labels here is actually really nice because when there's 3 arguments, I always forget the order, and so I use labels all the time when it comes to folds. So I'm going to use the same names as the same labels as Gleam does. So for the function, it's folding with, and the initial value is from, and the actual list we want to do is over. So let's bring that first. I guess that's the order. And then the function will be a function from, let's make that the initial type B. It's going to be a function of B and element A that returns a new B. Right. So fold R is going to have exactly the same arguments, and reverse will take a list and return a list. Okay, so I'm going to bring back the tests, and the first thing I'm going to do is make everything type check. So if I cd into list ops, and then I do Gleam test, this should fail for a whole bunch of reasons. So the first thing we're going to do is try and get those this file to type check. So those comments exist in the specifications. Basically, I'm going to read them and delete them. So those are no specifications here for dealing with large lists. Implementers may add tests for handling large lists to ensure that the solution have thought about performance concern. We're not going to worry about that. It's all good. Yes, so you see here the labels are also used. So list ops append list 1, list 2. And I guess it's so this is good, this is good. So having the names list 1 and list 2 indicate that this is the first and this is the second. So those are good names. Although maybe when we pipe something into append, maybe the one that we append to should come first, but let's not worry about that. Maybe we can check later. So this is all right. Concatenate list of lists. So whenever we have concat lists, I'm going to remove the label because we removed it before. So concat of an empty list should be an empty list. Concat of these guys should be, should flatten it, yes. What about this one? So here we have list of lists. And so concatenated, we should lose one level. Yeah, that seems right. This should type check. Okay, here we have filter. So we are going to take the lists, make it first here, and then this function that was represented as a string, we are going to implement. So we have x, and this will return x mod 2 equal 1. So this should keep the odd numbers. For an empty list, we should return an empty list. Not very interesting. Here we have a non-empty list, which should give us the odd numbers, right? Okay, length. Length should be pretty straightforward. Empty should be 0. 1, 2, 3, 4 should be 4. Map. Let's go with an empty list. So if we map an empty list with the function that returns x plus 1, that should return the same thing. I mean the empty list. In this case, we have 1, 3, 5, 7. And if we add 1 to each of these, we have 2, 4, 6, 8. Checks out. Okay. So for the function, ACK is the accumulator and L is the current element. The order of the 3 arguments should match the convention common to the language of the track implementing this. Yes. So this is the case for Gleam. So we can check out the standard library for lists. And fold, and the function should be B, so the accumulator first, and then the element, and that returns an accumulator. So we're doing the same thing here. So here we are gonna change the names. And so all of these instead of lists will be over. Yep. Initial, we're gonna change it to from, and the function we're going to change to width. And because we have the label now, we don't really care about the order of the arguments. And that's the beauty of labels. Okay, so let's implement this function over here. I don't know how often it's repeated, just once. So this is a product, so function of x and y. No, hang on, that's not what am I doing? Function of x and y will return x times y. And then this will be the addition plus, so function of x and y will return x plus y. Yep, and here we have division. X divided by y. Yep. Okay, so we have this message here. This test re-implements the test with UUID something something. Please identify and remove it. Yeah, basically, sometimes some tests are flawed and they're changed, and we are expected to remove them. But the generator is not smart enough at the moment to do this. So this test over here, I believe, has been re-implemented by this one. And the name of this one is fold L of an empty list. Why? Re-implemented to remove ambiguity about the parameters of the function input. They've renamed X and L to be accelerator, accumulator, and element. Yes, that's actually a good change. So I guess, yeah, all of the ones we've just made will be re-implemented. So this one re-implements this one. Well, let's just remove it. This one re-implements the plus one. And then this one re-implements the division one. So we can remove that. Good, we can remove those comments. And okay. Let's change this. So this will be accelerator element. Yeah, L is fine. Okay. Okay, those three should be fine. Now we have the same, but for fold right. So we have 1, 2, 3, and I'm guessing those three have also been re-implemented. Yes, we can get rid of them. Let's double check that the fold R in the standard library is also is also the same. Oh no, this is not reduce. Reduce is something else. Reduce is a fold when we assume that there is a one element and that we are taking the first element as a accumulator. But fold right is what we want, and the function is also BAB, right? So this is the same. So this should be okay. So you see that the addition and the product should give the same result. So here we have 2 and 15. We should also have 2 and 15 for the fold right, because it doesn't matter the order you do it in. But for division, the order matters. So in this case, we have 64. But in the other case, we have 9, because we are associating the well, we're going from the left and the right, but let's see in the implementation later. Okay, so for reversing, we don't need the label, reverse of an empty list. Yeah, that's pretty okay. So now I'm going to save, and I'm going to hope that, oops. So if I save and then the file doesn't auto format, it means I made a syntax mistake somewhere. So let's see, on 970, the compiler did not expect something. Oh, I have an extra bracket. I have another error somewhere. Let's check here. 76. Oh, of course. This is not. This is not a proper operator. Ah, and so now I saved it, just blinked altogether, which is good. So if I run the test now, they're all going to fail because I haven't implemented the exercise yet, obviously. But you can see that it compiles. So the types actually match. So this is half the battle. So at this point, we assume that the tests are okay, and we move on to actually solving the exercise. So let's do it. So we have list 1 and list 2 here. I'm wondering whether we let's make it a challenge, because if we use the standard library, it's not going to be very interesting because all of these functions already exist. So I like to I'll re-implement all of these functions, kind of just for fun. Otherwise, it's not very interesting. So for append, which is really a concatenation, so I'm gonna do a helper functions. I'm gonna call insert, I guess, or append 1, let's say, and this is going to take a list, and a single element, type A, and return a list of A. And so what I can do here is do a case case list. So if the list is empty, I'll return a list with a single element, right? And if the list is not empty, I will, okay, I'm not going to do that. I'm going to add at the beginning, maybe it's better. So let's say I have a list A and I want to prepend an element. That's a little bit easier. So if we have now, so if we have some element in there, we had a head and we have a tail. So when I prepend A, I'm going to have A and the head. Oh, you know what? I don't even need this. I just need to check if it's empty or not. If I know it's not empty, it's enough, so I can just go ahead and say list. Good. So now I have this helper functions. You'll notice that I didn't use the pub. The pub means public, because this is just useful for myself. And so append this is going to be, basically I will want to use prepend a whole bunch of times. Yes, so I'm going to do fold right. I'm going to fold over list 1. I'm going to fold from list 2. And I'm going to fold with prepend. So that means that I'm going to start from the list 2. I'm not going to touch it. And I will prepend all of the elements from list 1, one by one, starting from the right. And so to do this, I'm going to use the fold R function that I actually haven't defined yet, but I'll get to that. All right, concat. So now we have a list of lists and we just want a single list. That sounds like a job for folding. So I'm going to fold over my lists. I'm going to start with an empty list. And I'm going to prepend each of these elements to my empty list. And so I should end up with a concatenated list in the end. All right. Filter. So I'm going to, big surprise, fold over my list. And I'm going to go from 0. And here I'm going to write a little function. So for the list, oh, this is not list, it's lists. So for my list and each element A, let's say, I'm gonna do case function of A. Don't know if function is a good name, but maybe predicate would be better, whatever. If we get a true, then we can prepend A to the list. And if we get a false, we just return the list. Okay. Let's do length. Surprise, surprise, we're going to fold. So we're going to fold on the list, and we're going to start from 0. And we are going to ignore all of the elements, but just return every time we have this function, not lists, but length. And then we're just going to return length plus 1. Okay. And then map, surprise, surprise, we're going to do a fold. So we're going to fold from an empty list, and for each element we're going to prepend, well, let's call it A. We're going to prepend the function of A to the list. So each element we apply the function and prepend it to the list. Okay. Fold L. Okay. Here we come to the real deal. So just because we've implemented everything with fold R, it might be easier to start with fold R. So let's start with fold R. So let's check the list first. If we have an empty list, so if the list is empty, we should return B, which is our initial value. Now, if the list isn't empty, so we have a head and a tail. So we want to return, we want to take the function of the B that we have. We want to apply that to the head. And this will give us a new B. And then this B, we are going to, wait, is that right? No. So I think this will be fold left, but what we want to do here, let's do fold left first. As I solve it in my head, I might get it wrong. So this will give us a new B, and all we do from fold left is prepend that B to recursively to the fold L of the rest of the list. So this will be over the tail. It will be from, no, right. Yeah. We're gonna change B and go from there. So here we're gonna go through the rest of the tail, and we're changing the initial value to applying this function. And width, we are gonna keep the same function. Okay, that should do it for fold L, but for fold R, we're gonna do it a little bit differently. We're also gonna do a recursive function. We're gonna recursively use fold R this time. But now we are going to prepend function B of of a head. No. No, okay. We're not gonna apply it to B directly, but to the rest of the list folded over. So we're going to fold over the tail from B with the function, and then apply the function to the head. Hopefully that works. And then reversing a list. Let's try, how can we do that nicely? We can do fold L over the list from an empty list, and the function is going to be prepend. I believe that should work. Let's try what we got. I probably made some mistakes. Okay, unknown variable A, line 3. Yeah, great job. This should have been called element. Okay, let's run the tests again. On line 9, what did I do? The types don't match because it's expecting a list of A and it found A. How did it find A? Because I said that my fold R should give me an A, but that's not correct. It should give me a B. Yes. Fold L as well. I'm surprised the test didn't catch that. But I guess everything was an int, so it wouldn't catch that. Okay. Line 13. It expected a list of A, and it found a list of A. So we start with the list, and we're prepending. Yes, I should not use prepend, I should use append, so that this should match. Function A of line 21, did you mean function? Yes, I did. Line 22. I think I switched my arguments here. Line 34. Prepend. I also switched my arguments. Line 43. Oh yeah, that's initial. It's not B. B is the type. Of course. Okay. We have 4 failures. It's not too bad. I was expecting worse. Let's see. What did we fail? We failed concatenation. 1, 2, 3, 4, 5, 6. We got 4, 5, 6, 3, 1, 2. Yeah, I guess we messed something up here. Concatenations we failed. And fold L. Yeah, I think that's a different issue. Let's go back to the concatenation first. Very possibly, we could try a fold L, see if that fixes it. And it does, good enough. And then for the division, we have some problems. I remember there was a comment about it that I kind of went very quickly over. Re-implements to remove ambiguity. Expects division to preserve fraction. Integer division will not work here since it would compute 1 over 24 equals 0. Use the original test value if integer division is expected or required. I guess we can make everything floats and see what happens. Because we are not, we made all the functions generic, so we should be fine. Let's try it. Here for the division, let's add a bunch of 0.0. Okay. Let's see if that works. We might have some issues with so if we want to divide, we need to do point divided, I believe. We might have some issue with, no, it's not divided point. This is the operation for floats. And then you expect a floating point number as the result. Fair enough. Hooray! It all works out. So yeah, not too bad. Sorry, I went over this really quickly. I know that for beginners this is not so easy, but I've done it so much that it's already in my head. And it might take a while to do it, but I encourage you to do it by yourself and try and work it out. You don't have to use fold R every single time. You can simply, it's way easier to just use case statements for all of these. But I really do enjoy the folds in functional programming because you can basically do everything you want with a fold. So let's finish this up. So this is the solution. So before we submit a new exercise on the track, we should as soon as possible. And so that's enforced by the CI. So I'm gonna save this example solution in here. And this actual one, I'm gonna remove all of the implementations. And it will be to do instead. Okay, and this is just a helper function. I'm going to save, and you see that all the to-do show up nicely, which is neat. All right, I'm going to leave it like that for now. And I'm going to, I should actually Should have done that before. I'm going to check a new branch. List ops. Okay. Yep. So here, my generator was telling me, after implementing the solution, test and configuration, please run. So I have implemented the solution, the tests, but not the configuration. So there are two different things in the configuration to do. There's the configuration for the exercise itself. The only thing that needs to be done is adding my name, my GitHub handle here. Okay, and then the configuration for the whole track. So there are two things to change. My the generator always has this nasty bug. It changes this value from 3.0 to 3, and Exosystem doesn't like that, so I have to change it every time. I really should fix that bug. And then this is the name of the exercise. That's the slug. You have to give it a name and a unique ID. And then we have to say what it practices. I guess it's fair to say that it practices lists, because you are basically re-implementing everything in lists, but also recursion. Because that's how you define these things. And it's also prerequisites. And I am not sure whether we have other prerequisites. Let's see. Let's see the exercise over here. So what else have we been using? Case statements, I guess, is really important. Case. Otherwise, really not much else. So that should be so it should be okay. Difficulty. This is it's a hard one. Definitely at least 5, because it's probably a bit more complex than others. Maybe a 6. It really depends. For people who are used to functional programming, it's a lot easier than beginners. So let's make it a 6 and not think about it too much. Okay, and then now that I've done the configuration, I can take this, can copy this, and this will ask me if I have implemented all of these tests. I know that I have implemented them all, so I'm just going to add an I here, which means include them all. And this is going to create a configuration file here, test.toml, and say this test was added, this test was added, and this test was not added because that's some of the ones we have re-implemented. So all of this is automatic, we don't have to worry about it. And the last thing we want to do is run the formatter. So bin configlet format, update yes. And it seems like this file was not formatted, and it is now formatted. So I think, yeah, I just changed the formatting for that one. Okay, now I can do git add everything, git status. There should be 10 files from experience. I usually run a quick git diff to have an overview. Well, git diff staged. Okay, I've left some white spaces, can't have that. Can't have that. This file should really be formatted by config-lit. Instructions are fine, git ignore is fine, this is okay. This is my implementation, it's alright. This is generated file, nothing to change. This is okay, this is okay. This is okay. This is probably fine. Alright, so I'm going to push it. So I'm going to push it on the repo, and no, I forgot to commit it. Of course, I pushed an empty branch. So I'm going to commit and say add practice exercise list ops. Now I'm going to push and it's going to do something. There we go. There we go. Okay. I'm going to add a label. Say this was a practice exercise. I'm going to say it was medium work. And this exercise was added on stream, which is my very first stream, which is why probably things are not perfect, but I'll get better. All right, create a pull request, and hopefully Luis can review it at some point. And that's it for me. See you later.